Okay, question number 4. A particle moves in a straight line such that it passes through a fixed point O when t is 0. So there's first clue. It passes at point O at time t equals 0, where the t represents time measured in second after passing O. For t from 0 to 10, its velocity v meters per second is given by this equation. V equal to sine of 0.5 t plus 0.3 t negative 2 minus 2. Graph of v is shown in the following diagram. So this is v, this is x. Okay, find the smallest value of t when the particle changes direction. So it says is when the particle changes direction. When the particle changes direction simply mean the sine of v, right? The sine of v changes. When was the first time the sine of v changes is over here. So v start from negative 2, increase becomes 0 and positive, which means that this point is the smallest value of t when the particle changes direction. We find the value of this one. So we need a calculator. So we need to draw this graph. V equals 2 times sine 0.5 of x plus 0.3x minus 2. So we need to find out this graph. So this graph look like exactly look like that one from 0 to 10. So we need to find the value of x-intercept here. Come on, here. So got it. X equals 0. 0.69. No, 1.69. So x equals, not x. Find value of a t. So t equals 1.69, right? The displacement of the particle is measured in meters from origin. To find the range of value of t for which the displacement of the particle is increasing. This word simply meaning displacement of the particle is increased, meaning the velocity is greater than 0. When velocity is 0, this particle is at rest, doesn't move at all. When velocity is greater than 0, the displacement of the particle is increasing, which means in going to the positive x direction. So we need to find of t that the velocity is greater than 0 from here to here. So from this value is 1.68. So that value over here is 6.12. So it's going to be from t equals t is greater than 1.69 and less than 6.12. This is the answer. Find the displacement of the particle relative O when t equals 0. We need to find this is this value. Displacement of the particle when t equals 0. So the question is simply asking, we need to find s of 0. No, s of 10, the position of the particle at t equals 0. Do we know that we know the vt, so we can find st by integrating this function. Or we can simply use a calculator. So y3 is going to be go to math, integral of second function over here of x. So from 0 to 1, 0 to 10, if we integrate velocity of dx, will give us a displacement of the particle. So go to second quit math integral of this second function from 0 to 10 dx. So this will give us a displacement of the particle at t equals 10. So it's minus 213, minus 213. So equals negative 2.13. The unit is meters, right? Or we can put here from 0 to x, deleted. So this function y3 means this is the displacement function we'll see on the graph. So displacement function, when t equals 0, it passes through 0, right? So, and then the displacement particle at t equals 10. So over 10, we need to find the value. So we go to calculate the second function when t equals 10. The displacement here, as you can see, is negative 2.13.